So today we're going to be evaluating this limit. As you can see, it looks kind of like there's a lot of fractions we'll have to deal with today. So let's get into it. Starting off with, the first thing we should always do is try and input that solution, right? X is going towards 3, so let's see what happens when we put in 3. And I'm going to do this in purple just because we're going to see, as is a lot of times the case when we're working with limits, when you put something in, it just gives us 0 over 0, which doesn't tell us anything. That's not a solution. We're going to have to work a little bit harder. Now, you could use L'Hopital's rule on this if you wanted to, if you understand how that works and you've worked through that already, but it's going to be a little bit of a pain to do with all these fractions. So let's try working with algebra in this case. And the algebra in here is going to be a lot. So the first thing we want to do is we have two fractions in the numerator. Let's get a common denominator there. So our common denominator is going to be 3 times x. So our first fraction we're going to multiply by 3 over 3. And our second fraction we will multiply by x divided by x. And we'll leave our denominator alone. That just comes along for our ride. So let's rewrite this. So that gives us our limit as x goes to 3. And on the numerator, we are going to have 3 divided by 3x minus x divided by 3x divided all by x minus 3. All right, now our numerators, we can smush those two fractions in the top together, which is going to make this super nice. That gives us 3 minus x over 3x, and we're going to divide it out by x minus 3. Now, when we're working with something like this, we're going to make a little bit of a change here, right? We have too many division symbols here. So I'm going to add one more just so that we see where this is going. And we're going to remind ourselves that when we have two fractions, a over b divided by c over d, we can flip and multiply. So this is the same as a over b times d over c. So you take that stuff in the denominator, you flip it, and you multiply it. So that's why I took this x minus 3 and we divided it by 1. So now we can see that this is actually a fraction. We're going to flip this fraction and multiply it. So let's actually write that out. This is going to give us our limit as x goes to 3 of 3 minus x over 3x times, and now since we're multiplying, it will be 1 over x minus 3. All right, next thing that we see here that's a little bit of an issue here. It would be nice to take these two terms and cancel them out, but notice that they differ by a negative sign. In our first one, our negative sign is in front of the x, and in our second term, the negative is in front of the 3. So we are going to actually do kind of a funky little thing here that we are allowed to do. We're going to multiply by a fancy pants 1. And by that, I mean we are going to take one of these 1s and we're going to distribute that so that our term up top in our numerator turns into an x minus 3. So we're going to take this right here, and we are going to distribute it across the top. And we're going to leave the other negative 1 alone. So multiplying by a double negative 1, we haven't actually changed anything. We are just multiplying by a fancy pants 1. And this is going to allow us to multiply out, and we're going to be able to cancel things after we multiply things out. So let's actually write that out. We have that negative 1 that just stays as is. When we multiply that negative 3 throughout, we get negative 3 plus x over 3x. Our second fraction doesn't change at all. And x minus 3, these two cancel out. So isn't that lovely? Oh my gosh, this looks so much better already. So now we get a negative 1 on the numerator. Everything else has died out, negative 1 times 1. And a 3x on the denominator. And now at this point we see, oh my gosh, this is so much easier. Let's plug in that 3. This is going towards 3, so this is -1/9. And there is our beautiful solution with just a little bit of elbow work algebra involved. Thanks for listening.